The NEXT-C system, which is on board DART as a technology demonstration, is the next evolution in ion propulsion technology advanced by NASA's Glenn Research Center. And while its bluish ion beam looks cool, it's not a rocket flame providing the propulsion, it's actually electricity.
So the way an ion thruster works is that it utilizes electrical energy to ionize propellant and accelerate it using electric and magnetic fields.
Here's how the NEXT-C's gridded ion thruster works. If we slice it open, we see a large discharge chamber where a neutral gas is ionized. It's lined with magnet rings that push negative electrons away from the walls with a magnetic field. At one end is a xenon propellant injector and a discharge cathode which releases electrons. At the other end of the chamber is a screen electrode with a high positive charge and an accelerator electrode with a highly negative charge. Positioned outside the chamber is a neutralizer. Required for a reaction are an electron and a neutral xenon atom, resulting in a positive ion. The propellant injector releases neutral atoms into the discharge chamber. Electrons are simultaneously released from the discharge cathode. The electrons bounce around inside the discharge chamber until they collide with a neutral atom, and ionization occurs. The positive ion is then accelerated by the electrodes, providing propulsion. Electrons released from the neutralizer then pairs to the positive ions, and the process repeats, creating NEXT-C's highly efficient ion beam.
What NEXT does is that it increases the power level, you get more thrust out of it, it's more fuel efficient, it lasts longer, basically kind of improves things in almost every way and makes it very beneficial for end users to utilize.
Ion propulsion differs from a chemical rocket like the main engines of the space shuttle. They use energy stored in chemical bonds to heat up propellant, and then use that thermal energy to accelerate a gas. This produces a lot of thrust, which is great for overcoming gravity, but less useful for propelling spacecraft out into the solar system.
Because we use electrical energy, we can accelerate propellant to much higher speeds. And what that does for us is that it makes the engine more fuel efficient, which means that a spacecraft doesn't need to carry as much propellant in order to get to its destination.
If this demo proves successful, NEXT-C will be ready to propel even more challenging NASA science missions to destinations such as asteroids, comets, and the outer planets.